So hello, this is our group project. It is known as Team 3 or aka Unknown Forces Volume 2. And this is the best engineering group slash team. Okay, this is my colleague Alyssa who's going to explain the problem statement.
Thanks, Ella. So for our project, we examined an engine hoist where me and my teammates are going to be looking at all the reactions at the several pins and fixed supports, and we're also taking into account the weight of the engine. So my colleague will next explain the plan for our project.
For our first plan, we examined the structure of the individual members, and then we moved on to plan 2, which was we drew out the free body diagram and we see what we had to do. And for the last step, we just used the calculations of how we've been doing the statics equilibrium equations to find the forces and reactions.
For our group members, our assigned tasks were that Marco was going to figure out the forces acting on the hydraulic cylinder A to B. Saulo's going to do the reactions at pin C. Elizabeth is going to do the reactions at support D. I'm going to do the reactions at support E, and Arturo is going to do the reactions at pin G. For our free body diagram, we label each reaction in forces acting on our diagram. That's what we have for our free body diagram.
So our plan was to start with finding the force in FAB. To do this, we used the cosine rule to find the angle theta in triangle ABC. So as you can see in our drawing, we drew out the triangle, and using the cosine rule and sine rule, we were able to find the angle theta to be able to proceed to calculate force AB.
Okay, so for my part, which was to calculate the force AB, we took into account the theta that we just got using the cosine rule. We took into account also that the beam was massless. And to figure out this force, we just needed to do a summation of forces about point C. And we just did the weight of the engine times the distance, which was 1.5 meters, minus the vertical force of the force AB times the 0.3 meters. And we got the value right here.
So in my part, so I have to find the reactions at pin C. So I knew that I had to apply the equations of static equilibrium to find the reactions at C, which is going to be the X and Y directions. So in this case, for the X directions, I knew that I needed to add, to find that, I needed to use the number my colleague Marco did, the force of AB times the cosine of the angle of our engine. And then that's how we got our value for the reaction at X. Yeah, and then for the reaction at Y in the Y direction, we did pretty much the same thing. So I did the force reactions of AB times the sine of angle plus the weight of the engine. In this case, I got the reactions of Y value, which was a negative. And yes.
Okay, so moving on to support D, I drew a separate free body diagram for member CBD, as my teammates have already calculated the force AB and the reactions at pin C. I was able to use those to calculate the reactions at support D. So using that free body diagram, I was able to find the horizontal and vertical forces, and also the moment about support D.
Okay, to find the reaction at PG, all I had to do was find the Y, X, and Z, But for my occasion, I only had to find x, because my z and y were 0. So I had to find the f of x, which was only the entering of the weight. So it was 200 for mine.
And yes, for me, the reactions at support E, first, in order to calculate it, I found that the reactions at support E, I found that the force members of A and B and DC, I found it was going to be 0. So I took the vertical force of ATEY was equal to the W. So finding the moment along E, I know that was perpendicular from C to DE. So I let it equal to CX. So I got the cosine of theta equals CX divided by 0.45 plus 0.85, which I found out that CX was equal to 1.28. I plugged in the equation, I got the reaction of E was 5.56 W.
Thank you. This is our finalization of our group project, and then thank you very much.
Thank you.